solve problem on kinematics of rigid body. Let's see what is given in problem. Figure shows the crank and connecting rod mechanism. The crank AB rotates with an angular velocity of 2 radians per second in clockwise direction. Determine the angular velocity of connecting rod BC and the velocity of distance C. Lengths are given. Length AB is given as 0.3 meter and length CD equal to 0.8 meter. Figure of this crank and connecting rod mechanism is given on next page. Just see. Now in this figure, AB represents crank, where it is given in problem crank rotates in clockwise direction and piston C has to slide in horizontal direction only. Therefore, if you want to find out what is angular velocity of connecting rod BC as well as linear velocity of point C, first we have to decide which link performs which type of motion. Link AB or crank AB rotates about this point A, that means hinge support A. Therefore, crank AB performs pure rotational motion. As it performs pure rotational motion and omega is in a clockwise direction, linear velocity of point B will get perpendicular to AB. As it is perpendicular to AB, if I will represent like this one is a linear velocity where this VB is perpendicular to AB. Now for link BC, which doesn't rotates about any particular fixed center of rotation, that means link BC performs general plane motion. As B moves in downward direction, slider C has to slide only in horizontal direction, rightward or leftward. If you want to decide, that depends on linear velocity of point B, which is in downward direction. That means slider C has to slide in rightward direction. Therefore, VC rightward. Now to represent ICR of a link BC, we'll draw perpendiculars to VB and VC. If we draw perpendicular to VB, we will get same line AB, continuation of same line AB, because VB is already perpendicular to AB. Therefore, we will draw perpendicular to VB means same line AB will get. Perpendicular to VC, if we draw VC horizontal, that means perpendicular to VC is a vertical line. What point of intersection we will get of these two perpendiculars drawn here? This one is perpendicular, this one is here perpendicular. Point of intersection represents ICR. Now in triangle IBC, length AB and length BC is given. Length AB is given as 0.3 meters and length BC is given as 0.8 meters. As this angle is 30, same line I represented here, that means this angle must be what? This angle equal to 60 degree. Now in triangle IBC, length IB and IC, if you want to find out, one length is known and opposite angle is known. Other two angles, if you want to find out, say this angle, once you will get this angle 180 minus these two angles will subtract, what will get here? Third angle. But for that one, you must know inclination of BC with horizontal, say angle alpha. Now if you want to find out angle alpha, in this triangle ABC, can use sine rule. Definitely one length is known AB, opposite angle you have to find out. In other pair, 0.8 length BC is known, opposite angle is known, that means angle alpha is possible. Therefore, what we'll do, in triangle ABC, we'll apply sine rule, we'll find out alpha. Once we'll get alpha, 90 minus alpha will get this inclination. Once we'll get this angle, in triangle IBC, we'll find out third angle, subtracting these two angles from 180. Once we'll get third angle, then applying sine rule in triangle IBC, we'll find out IB and IC. Therefore, next step is what? To find out angle alpha. using sine rule in triangle ABC. In triangle ABC, if we use a sine rule, in this sine rule, angle alpha you have to find out. Therefore, if we take AB upon sine of opposite angle alpha, and what is known, length BC divided by sine of opposite angle is 30 degree. Length BC is known 0.8 meter, length AB is known 0.3 meter. Therefore, if we substitute value, AB is 0.3 divided by sine alpha equal to BC 0.8 divided by sine of 30. That means angle alpha comes out to be, if you use calculator and if you find out, angle alpha is 10.81 degrees. Once we will get angle as 10.81 degrees, again we will see our figure. Once we will get angle alpha, what other part is possible? Now this angle alpha you are getting, as you are getting angle alpha 10.81 degrees. Now this angle is easily possible. It is 90 minus 10.81. That means this angle comes out to be 79.19 degrees. 180 minus 60 minus 79.19. What angle will get is what? 40.81 degrees. Now in triangle IBC, if we use sine rule, we will get what? IB upon sine of 79.19 equal to IC upon sine of 40.81 equal to BC upon sine of 60. Therefore, in triangle IBC, again we will apply here sine rule. In triangle IBC, if we use sine rule, IB upon sine of opposite angle, that is 79.19, IC upon sine of opposite angle 40.81 equal to BC, where length BC is known, which is given as 0.8 meter, divided by sine of 60 degree. Unknown terms are IB and IC. Therefore, if we find out, length comes out to be IB equal to 0.91 meters and IC equal to 0.604 meters. Once we will get these two lengths, now easily linear velocities and angular velocities are possible. As you know, the lengths will start from rod AB. We'll see on next page again. For first bar, that is for bar AB, if you want to find out linear velocity, it is always V equal to R omega. Therefore, VB, if we find out, as it rotates about point A, radius of rotation is what? AB, and angular velocity of rod AB. What is known? Length AB is known 0.3 meter. Omega AB is known, that is 2 radians per second. Therefore, AB will substitute here, omega AB will substitute, so that VB, linear velocity of point B, comes out to be 0.6 meters per second. This one is the first part for link AB. Next link is link or bar BC. Now, as you know, linear velocity of point B, again if we use VB, for VB now center of rotation for link BC is I, therefore radius of rotation becomes AB into omega BC. Therefore VB is 0.6, IB length you have calculated, which one is 0.91 multiplied by omega BC. Therefore omega BC comes out to be 0.659 radians per second, and that is also in anti-clockwise direction. Once you will get omega BC, velocity of piston or slider is possible, which is IC, means radius of rotation. into omega BC. Therefore, IC is 0.604 and omega BC what we have calculated is 0.659. Therefore, linear velocity of point C what will get 0.398 meters per second, and the slider slides in rightward direction. What is asked in problem? What is the angular velocity of connecting rod BC? That 1.659 radians per second anti-clockwise, and velocity of point C is 0.398 meters per second rightward. Thank you.